about derivatives and antiderivatives of logs and exponential functions. So there's not going to be lots more rules that we're going to learn for derivatives and antiderivatives. So the first one is we're going to work with the natural log function first. So the rule for the derivative of the natural log function, natural log of x, is 1 over x. Now let's say you have a composite function. So if you are taking the derivative of the natural log of u, where u is another function, this would be 1 over u, and then you just have to remember that you do the chain rule, so of that inside function, so times du dx. Okay, so let's practice a couple of these rules. So the derivative of the natural log is 1 over the function that you're taking the log of, and then you always have to remember that you're going to do the chain rule. Sometimes it is helpful to rewrite the problem using properties of logs. So this is really natural log of x plus 1 to the 1/2. And if you remember, when you have exponents, you can rewrite this problem by bringing that to the front. So I'm going to go ahead and do that because that's going to make it easier to take this derivative. There is a list of the properties of logs down here if you forgot. So that's this one right here. You can pull that exponent in the front. Okay, so this derivative, just leave the 1/2. 1 over x plus 1, chain rule would just give you 1. So this is one where it's very helpful to rewrite it with properties of logs. So I can rewrite this. Notice the whole thing is raised to the 1/3 power. So like we just did in the previous problem, we can bring down the 1/3. And then when you are dividing, remember it's the same as subtracting the log of the two functions. So I can rewrite it like this. And this is going to make it much easier to take that derivative. So leave the 1/3 in the front. The derivative of this piece is 1 over x squared minus 1, chain rule, minus the derivative of this piece is 1 over x squared plus 1, chain rule. Okay. This one here, be careful. People want to bring the 2 down in the front, but that would be if I gave you this. Then you can bring that 2 here. This is the whole thing raised to the 2nd power. So when you take the derivative, you're going to bring down the 2, reduce the power by 1, and don't forget, chain rule on the inside function, which is 1 over x. I'm going to rewrite this by pulling that 1/2, the exponent, to the front. So derivative is 1/2. 1 over 3x plus 1, chain rule, times 3. This is the same as bringing that 3 to the front. Derivative is, leave the 3. Derivative of natural log of cosine 4x is 1 over cosine of 4x. But notice there's 2 layers here. So the chain rule says you need the derivative of the cosine, which is sine, and then you need the derivative of the angle, which is 4. Okay. Now, we're going to do the same thing, but this time we're going to do it with what if you have a log that's not a natural log. So you have other bases. Basically, what we're going to do is use the change of base formula from pre-calc. So we're going to change everything to natural logs and then just use the rules that we learned before. So this can be rewritten, this is your change of base formula, as the natural log of x over the natural log of 3. Right? This is what the change of base formula says. You can change it to any base. So now when I take the derivative, this is a number. So I can pull that out in the front. And the derivative of the natural log of x is just 1 over x. Same thing here. This can be rewritten as natural log of x over natural log of 10. Now I can take the derivative. I don't want to use the quotient rule because this is just a number, so we can pull it in the front, times 1 over x. Same thing here. This would be natural log of 2x plus 1 divided by natural log of 5. Derivative is, pull that natural log of 5 in the front because it's just a number, 1 over 2x plus 1 times 2. So I would just use the change of base formula every single time, but there is a general rule for when the base is not e, like a natural log. Notice on all of these problems, really you end up with 1 over natural log of a, whatever that number is, times 1 over x. And then if you have a composite function, the rule would be 1 over natural log of a times 1 over u times du dx. So it's up to you if you'd rather kind of memorize these or just use the change of base formula. I just use the change of base formula every single time. Okay, so I'm going to do these problems by using the change of base formula every single time. So when there's no base written, this is really a base of 10. So this is natural log of cosine of x over natural log of 10. Derivative is 1 over natural log of 10 times 1 over cosine of x. Chain rule here. There's my derivative. I'm going to rewrite this as natural log of 2x over natural log of 4. Derivative, pull that natural log of 4 out front, 1 over 2x. Always do chain rule on whatever you put there. This can be rewritten as natural log of x over natural log of 6. 1 over natural log of 6 times 1 over x. And the last one here, we're going to rewrite it like this. So derivative is pull out that 1 over natural log of 4, 1 over x squared plus 1, chain rule, times 2.